Hello MYP5, we are on page 535 and today we are going to look at the sine and the cosine graphs. You have looked at a number of graphs already and now we are going to look at the sine graph and the cosine graph. Remember sine and cosine were in trigonometry ratios. Okay, the sine graph. Right? The first one we're looking at the sine graph. Sine graph has its standard shape like how quadratic graphs have a U shape, the exponential graph has increasing shape, and a straight line graph has a straight line shape. Sine graph, this is the shape for sine graph. My original curve y is equals to sine x, and then later on you'll see we are involving values here and here, which is going to dilate it, stretch it, reflect it, or translate it. So we are going to look at basic sine graph. A basic sine graph will have this shape. That's the shape, standard shape of a sine graph. You can look at the shape and decide whether it's a sine graph or a cosine graph. So one complete shape will finish at 360. On the x-axis, I have the angles 90 degrees, 180 degrees, 270 degrees, 360 degrees, right? And on the y-axis is the highest value of the graph and the lowest value of the graph. Since nothing is written here, that means it's 1. That's why my maximum value and minimum value is 1 and -1. Since no number is written here, we understand that it's a 1. That means there should be one complete shape between 0 and 360. Okay, so this is called period of the graph. One complete graph, the period of the graph here is 360 in this case. That's one complete shape is finishing at 360, and the highest point and the lowest point on a graph is called the amplitude. Okay, we will look at this more into detail little later. Okay, let us now look at the cosine graph. The cos graph has this shape. That's the standard cos graph shape. One complete shape should be finishing at 360, right? Likewise, we will need a number here and we will need a number here once we'll start to transform this. Okay, and you will see that at 180 there's a symmetry. These are the points that's clearly been shown there. Okay, in this case again, 1 and -1. 1 is my amplitude, that means my maximum point and my minimum point of the graph. And my period of the graph here is 360. That means one complete shape is finishing at 360. Right? Once again, amplitude is the minimum and maximum value on the y-axis. Amplitudes will be written before the word sine or before the word cos. If there's a value written here, that means that's the maximum or the minimum. Right? We'll use the symbol A for amplitude. They will be always written before sine and before cos graph. Okay, we are now going to look at the example from our textbook, and the example is on page number 537. Okay, once we look at that, in your textbook, amplitudes are explained here. Okay, if we look at this one, right, can you see this is a sine graph? It's finishing one complete graph at 360. There's something on the negative side as well, right? That means at the one that I explained, my graph started from 0, but it can continue on the other side. It can further continue like that, right? Cos graph, can you see it starting from 0, finishing at 360? You can always extend it on this side, or you can further extend it after 360, right? Okay. Alright, let us now look at example 1. It says, write down the function of this graph. Okay, before looking at the answer, we can see this is the complete round. That means y is equals to 360. Right? That means my equation can at the moment, without looking at the amplitude, should be y is equals to sine x. One complete graph between 0 and 360. My period is 360. Okay. And then I have a minimum value and the maximum is 3 here. and below 3. That means my value of the amplitude is 3. Okay, so it's supposed to be y is equals to 3 sine x. Right? Now we are going to look at the period of the graph. Period of the graph means number of the complete shape of sine in the cosine graph between 0 and 360. So period will be written, we will use b as our value for the period. So y is equals to sine bx, and in this case, in the cos case, y is equals to cos bx. To find how many complete rounds are between, or one complete round will finish, so we're going to be doing 360 divided by b. 360 divide by b in the cos one. Once we look at the example, you will be able to understand that much better. Okay, right, let's look at this one. First, let's see what kind of graph it is. Oh, it's a shape of a sine graph. That's my sine graph. That's my sine graph. Okay, my amplitude is 3 and negative 3. My highest point and lowest point is 3 and negative 3. Okay, how many complete graphs are there between 360? This is one complete graph, and that's then another one starting from there. Right? So between 0 and 360, I have two sine graphs. That's why my equation is y is equals to 3 sine 2x. There's two sine graphs between 0 and 360. And you have to find the period. Where does your first sine graph finish? You will do 360 divided by 2, and you will get 180. That means the period of the graph is 180. First sine graph will finish at 180, then the second one will start after that. That means the frequency, there's two sine graphs between 0 and 360, and the amplitude is 3. Thank you.